Hi everyone, this is Dalton from Group B. I'm going to talk briefly about manufacturing processes and how these relate to the construction of a themed beer tap handle for Clark Hall Pub. Essentially just a quick brief overview of manufacturing. There's two subgroups which I researched. There's mass reducing manufacturing processes and then mass conserving processes. Essentially, mass reducing processes are anything where you take your raw material and then remove excess material to create your final product, while mass conserving processes are anything like molding, casting, or 3D printing, where all of the construction material goes into the final product. With regards to the scope of my group's project, we're looking to construct our handle largely of either wood or aluminum. So this essentially limits us mostly to mass reducing processes, just because of the fact that the resources required to cast or mold aluminum are beyond the scope of this project, and these processes aren't possible with wood. So within mass reducing processes, the functions that are available are the specific processes that are available to us are at the school are turning and milling. Essentially, turning is where using a lathe where you take a cylindrical or hexagonal object and then you turn it down to create your final product. Using this technique, you can perform a variety of functions. You can either reduce the outer diameter of the spinning object, or you can reduce its length. You can create notches, grooves, bore out holes, make tapers, radiuses, little fillets, or make round ball-like features. And in terms of milling, which is basically a process where you use either a 3, 4, or 5-axis mill, and you essentially secure a piece of stock onto a table that moves around a stationary tool for 3 and 4-axis mills. And essentially, what these allow you to do are perform many of the same functions as a lathe. You can still drill and bore and create tapers and whatnot, but you can also perform features that aren't non-circular. So you can create anything with sharp corners. Say if you want to etch out a deck going onto a sheet of metal, you can do sharp corners and straight lines, whereas on a lathe you're limited to anything which is you're limited only to things which are able to be done in a circular pattern. So that's why milling for some things is preferable. And now I'll just talk briefly about the effect of material on manufacturing process. Again, with relation to what my group's doing, we're considering aluminum, specifically the 6061 alloy, which is essentially mild grade aluminum, because the beer tap handle doesn't really require anything super strong, because it's not a part which undergoes overly high stress. And we're also considering wood. So when we look at the effect of using either metal or wood on manufacturing milling or lathing, essentially the technique, the areas that we have to consider are the technique required, setup time, turnover time, and then the costs incurred in using these processes. In terms of skill required for both wood and metal, they're roughly similar, although for metal more skill is required just because of the fact that you're dealing with a more dense and stronger material, so it's much easier to break tools or break the part that you're making, just because of the higher stresses involved. In terms of setup time, it's roughly similar for both machines, and in terms of turnover time, which is the time it takes from setup until your product is completed, or until the process that you're doing on either the lathe or the mill is completed. For wood, it's significantly shorter, just because of the fact that wood is much less dense and softer than metal and than aluminum, so the average cutting speeds are much higher. So in that sense, wood is preferable for turning and milling. And in terms of the costs incurred. The machines used to turn or mill wood are roughly similar, so there's not a large difference in cost there. Although the bits, like the actual tool bits required to either mill or turn metal, must be much stronger. Either like they must be constructed of high speed, very strong steel, whereas for wood you can simply use a hand file while on a lathe. So in that sense, the cost for performing excuse me, any machining process on metal is certainly higher than it would be for wood. Anyway, thank you for listening.